I didn't show any work. Ah, okay, good. Good. I can't reduce. It's okay, I'm just a math teacher. Okay. Where's my work? But what did I do? I'm going to do it the old-fashioned way, and then I'm going to show you a new way, and you guys have to choose which one you like. Old-fashioned way. The new way I learned in Uganda a few years ago on a mission trip. Sat in a math classroom, and I was like, cool. Anyway, old-fashioned way. 2 divided by 3/5. How do you divide by a fraction? Multiply by a reciprocal. But did you guys remember 2 is 2 over 1? Good. Equals. How do you... See, that's why this was the easiest one. But maybe not. But to divide fractions, multiply... So you're going to... Does that make sense? This one, most of you would have wanted to get common denominators. Not all of you. Some of you might have said 1 3/5 and then gotten like a improper fraction and then gone from there. That's another way. Like if you're logical. 5 over 5 is 1, but remember, if you multiply anything by 1, it remains the same quantity. So to get common denominators, we multiply by 1 creatively so that we can get, I'm not trying to change the 2 to 5 over 5, I'm trying to change the 2 to 10/5. Does that make sense? So it's still the quantity 2. 10/5 minus 2/5 is 8/5. Now here's where it gets a little bit tricky. 8/5, and here's where it gets a little weird. 8/5 is getting divided by 4. Which means 8/5 is getting multiplied by 1/4. Hence how I got my 8/20. Actually, I did it a totally different way, but that's okay. 8/20. And then you could simplify to be 1 and 2, or 2/5. That's a 5. But no, it proves a point. Like there are certain things in math along the way that theoretically you mastered, but you're still making mistakes on it. And it's just natural. Like I have this because every year some kids really hate complex fractions. With numbers, put trig in, well, how are you supposed to succeed? Does that make sense? So we're reviewing with numbers so that once we have trig expressions and complex fractions, you won't totally freak out. But pause. Can I show you my other way? Cool. Ready? I actually do this. What? I multiply top and bottom by 1 creatively, like Joe was asking a second ago. Because if I multiply by 5 over 5, guys, what's anything times 1? If I'm multiplying this thing by 5 over 5, I'm not changing the value, I'm changing how it looks. 2 times 5. What's 5 over 5? Huh. But I wouldn't multiply this one by 5 over 5. It wouldn't help. I wouldn't by 2 over 2 or 3 over 3. I would multiply by 6 over 6. Because it would be the common denominator. What's 3 and 6 become? What's 2 and 6 become? And 3 times 5 is? I can do mental math with this. Oh, but that one's going to be bad, right? I'm going to multiply by 5 over 5. But, attribute. What's 5 times 2? What's 5? Oh! Okay, I couldn't reduce. Lo siento. But besides that, I was right. Can't be perfect all the time. Anyway, just kidding. Never perfect. But, coming back. Maybe. maybe something you should try. But do you have to? No. You could be super snazzy and get common denominators and then go ahead and put them together and then see that you're dividing by 4, which is really multiplying by 1/4, and then go ahead and multiply and simplify. So see how many steps that took? What are we doing in section 5.2? Verifying trig identities. Ooh, verifying trig identities. Don't you have to show me step by step? What if you needed to simplify a complex fraction as one step to the whole process, but you had to, look at number 3, show me 1, 2, 3, 4 different steps to that step? Ugh. How much work did I show for number 3? Just an idea. Let's go ahead and go back to section 5.2 and figure out why on earth did I make you practice complex fractions for this. Go, 5.2, open. Get it ready, get it written down. How are you going to verify? By drawing a, oh dear, by drawing a what? T, there we go. Because you're going to do it my way. Can you look at the steps in Calc Chat? Yes. Can you write it the way they do? No. Very first step is write down the problem and write it down correctly. Wouldn't it be really sad, and it happens every year, if you go to do homework and you write down the wrong problem? What if you write down part of one problem and part of another? It'll probably never match. Happens every year. Either you write down the wrong problem or you write down part of one and part of the other, or you write it down incorrectly so you were on the right number. Just be careful. Just be careful. I know it happens in all math homeworks, like probably wrote down something wrong, but on the problem first correctly. Then draw your T. Then what's the first step? Pick a side. Which one? Oh. 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 Do you remember which one we pick? The most complicated, because we want to do stuff to it. What could you do to him? 1 over cosine? Then what? Choose the left side. Does that make sense? Okay, so wait, how do we choose it? How do you show me you're given? Okay, so write it down. And as you're writing it down, be thinking, what can I do to it? I have a secant. I have a cosine. You can look over to the prove, because now this is established to be your prove on the other side. You can look at it and say, I want to get there. I want a secant at the end. So what's not there? The ones, but you don't want to go adding and subtracting ones all over. That's going to get really confusing really fast. Look at the trig. What trig maybe could we change? Okay, you have options. Some of your brains are going to say secant should be 1 over cosine. Why? Because that's just how you would start if you didn't look over there. Secant, 1 over cosine. Whew, it's easier in my brain. But others of your brains, if you're looking here, maybe you wouldn't change secant. Maybe you would change. What would you change cosine to be? Well, sadly, I know some of you guys are thinking about 1 minus cosine squared. The problem is I don't have 1 minus cosine squared. Don't write this down. If I was to try to get cosine squared, couldn't I multiply? Okay, fine, if I do that. I could do that, and then I could go ahead and I would get cosine minus cosine squared. Does that match the property? No, it's 1 minus cosine squared. Some of you are like, okay, well, that was illegal. I get that, but I still think I should be using that cosine squared Pythagorean thing. So you're like, oh, square it. Yay! Square, square. I'm just squaring everything. Oh, you just went to your prove. That's illegal on a proof. You're not allowed to go to both sides. So you can't go squaring, and even if you did, you would have 1 minus 2 cosine minus, nope, plus cosine squared. You're in trouble. Sadly, my advice, your brains will think you can, but you can't. If there's no squared, don't go to Pythagorean. Your table, Pythagoreans are out. I would say reciprocals or quotients, but neither of those are quotients. Look at your reciprocals. You guys get to choose. I would only do one. This is kind of in line with the advice I gave someone yesterday who tried to change everything and it kind of got messed up. Just change one. Do you guys want to change secant theta to 1 over cosine theta, or do you want to change cosine theta to 1 over secant theta? Okay. Someone had a strong opinion, they went for it, so I'm writing it. Why am I saying only choose one? Yeah, it's a problem when we have two different trig functions and somehow things are supposed to simplify to get down to. If we can get it all in terms of the same function, math rewards you when you, usually, in these types of problems, math rewards you when you try to get it all in terms of the same types of functions. Why did we review complex fractions? Because we have one. Can we go look at number 3, the third example from our bell work? What do you guys want to do? Do you want to do it this way? We have to somehow simplify the complex fraction. I'm warning you, it's the only way to go. It's really just math. It has nothing to do with this section. It's math. Do you want to do it this way, common denominators, and then go? Or do you want to try the shortcut?
Let's try it.
Okay. To try the shortcut, didn't I go looking for the little baby stuck denominators? If there were more than one, I combined them. If there was only one, I used it. So who's the baby stuck denominator here? So multiply top and bottom by cosine. It's really just math. It has nothing to do specifically with this section. Just like we had to do in that one. We're going to have to distribute. What happens when you distribute on top? 1 minus math also rewards you if you try to think ahead to the next step before actually taking it. If your brain is so stuck on multiply, 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 and you forget the big picture, you might lose what you should or shouldn't do in the denominator. Numerator, okay, distribute. 1 minus cosine. Whew! Denominator, distribute. Why am I going to say don't distribute? Just stop and rewrite it, because now, what happens? It's totally legal to reduce an entire factor. Oh my goodness. What's left on top? Who's 1 over cosine? Complex fractions can look hard, but when solved or simplified properly, can be quite QED. Thus, it has been easy. Now, I know some of your brains, that shortcut just isn't making sense. Some of you guys are like, I get it, that's awesome. But let me just show you the other way. You could have done it another way. You could have done it the common denominator way, which was really, to be honest, in middle school, maybe even beginning of high school, this is the way your teacher would have shown you. In elementary, get the common denominators, make a fraction on top, or maybe like use mixed numbers. 2 minus 2/5 is 1 3/5, depending on your brain. Make that an improper fraction, then divide by 4, multiplying by 1/4. So let me show you this way, because if your brain sometimes like takes math and ingrains it, and that's the only way you can ever do it from there on out, there was another way to do this one. Let me steal him fast. Let's close. You would have started off, you still would have a way around that. Okay, technically there are two different ways of doing it. One way is you could have changed cosine to be 1 over secant. Having everything be in terms of secant, you would have multiplied top and bottom by secant. But let's just assume that you still went the 1 over most. Cosine is better than secant. If you had done it the other way, you would have had to, just working in the numerator, like we did with multiplying by 5 over 5, you'd have to multiply the 1 by cosine over cosine. Because then you could go ahead and have, like, you would have still just had that same denominator. Then you could have put those two together, 1 minus cosine of theta, all over cosine of theta, all over 1 minus cosine of theta. Then you could have done 1 minus cosine of theta divided by. Then you would have had to see that as a fraction and then multiply by the reciprocal. Either way, you end up with secant, if you know that 1 over cosine is secant. Either way you end up with it. This it just says, hey, let's get that numerator all nice in one fraction. Sweet, that's one fraction. Here's, over 1, another fraction, and then simplify. Both ways work. Both ways totally fine. I just like how many steps this saves. But what's the shortcut? Whenever you have a complex fraction, you can look for the denominators. If there's more than one, you'd have to do like a common denominator thing and put it all together, like we did with the 2 and with the 3. You could do that with trig 2. Maybe there's a cosine somewhere and a sine somewhere else, so you would do sine and cosine on top and bottom. But just be careful. If you have some sort of polynomial or multiple term expression, you'd have to distribute. But what's on top multiplied has to be multiplied on bottom. Sometimes you leave it factored for sake of what's coming next. Sometimes you actually bring it in. But it saves you a lot of work if you can understand it. But if you can't, old-fashioned works too. Okay? Complex fractions. How we feeling? Give me like a thumbs up, thumbs middle, thumbs down. Okay. Not a lot of thumbs down. How many of you guys would have given me a thumbs down at the very beginning when I said 2 minutes ago? Yeah. Just head nods are okay. Probably like half the class. Complex fractions are tricky, but they're not impossible, and they're actually a lot easier than you probably remember from middle school if we just review it a little bit, which we tried to do. All right, kids. You, in your groups. See how far you can get. Wait, let's collaborate a little bit. Just look at it real fast. What do you think? Left side or right side? Joe's going to start with the right, but what do you think my advice is? Why? Can anyone give me a reason why I'm going to say the left? Maybe the cosines, but I see cosines over here. I was actually thinking I can change tangent to be sine over cosine complex fraction. That's one thing. But I also see a fraction and a non-fraction where I could get a common denominator. I see a couple things I can do here. Common denominator, both. So I see things I can do. Here I'm like, yeah, right? I can do stuff there. I don't know about there. Okay, ready, set, work together. No, like turn right away, work together. What's something that you see? The common denominator thing makes sense? Sine over cosine? Work together though. No lone people on this one. away. Good so far? First person I see that feels with confidence or thinks with confidence they know an answer. What do you guys want me to do? Common denominator or tangent? Sure. It's not going to make a huge difference either way. You guys see why I have to, right? Somehow I have to get those two together. If you did sine over cosine first, I can show that too. You can just wait and see if this makes sense. I'll come to your way in just a second. But I'm saying, okay, what if we did common denominator first? Pause. Do you see any tangents? We have to somehow change tangent to sine over cosine. I'm going to pause on this one and see if anyone can finish from there. Meanwhile, I'm going to go ahead and go dual page it. And I'm going to show what could have changed or what would have been different if you had gone for the tangent first. Both ways work. But if you're kind of here, keep going and see if you can finish it. If you're not, hold on. I'm coming to you because hopefully you did my other hint. I didn't do my first hint. Hopefully you at least did my other hint. Because I only get two. On the math. I had experiences with just mine later, meaning it came pretty easily until college. But it wasn't easily like I never stopped. If I kept working, I usually understood what was going on. Yeah. But the majority of the kids I've taught over the last 10, 11 years doesn't come easily. So I've had to work to figure out how to make it make sense. With one-on-one tutoring, like kids that aren't in this school. Actually, I was doing that in college too. And then teaching. I've had kids that have barely made it through Algebra 2 in high school, needed to get through business calculus in college, and I tutored them through like geometry and Algebra 1, Algebra 2, calculus, and then business calculus. And they've done pretty well. Sometimes it just takes longer for things to click. Or you have to see it over and over and over again, and then like a year later, oh, it makes sense. But the key to whoever it is and wherever you're at, anything new, you got to practice. My other hint was changing hint. Doing it easier because I have these properties, these identities memorized. So in my brain, I'm like, oh, tangent equals something. Oh yeah, sine over cosine. Let's try that. This one was more of a math step. You can't combine two pieces unless their denominators are the same. That's a math step. This is just a, I don't know, I have an identity. Quotient identity. Ugh. But now what? Do you guys see a complex fraction like the numbers that we saw at the beginning of class? Right? So we could technically do our trick. You could do cosine. Cosine squared. Remember how we have to distribute cosine times 1? Don't the cosines cancel? Sines left? Hey! It's not perfect, but it's close. What would you have to do next here? Common denominators. So if you guys notice, this one we did common denominators, and now we're going to have to do a complex fraction thing. This one we did the complex fraction thing, and now we're going to have to do common denominators. That's why I gave them to you as my hints. Either way you went, you had to do both. So I'm going to give whoever was over there, I'm going to give you guys a little bit of time to try common denominators and see where you get. People who've been working over here, let's see what should have gone next. Well, maybe you saw the cosines went away. Could have gone away. But you still would have had to do common denominators, complex fraction. This one would have gotten negative sine cosine all over cosine. That's messy, I apologize. Cosine of x. Oh, so close. Yeah, that's one way. You can multiply top and bottom by a -1. The other way is you can factor out a -1 and then reduce. Whichever way makes more sense in your mind. You can multiply top or bottom, top and bottom. Remember, it has to be both. By a -1, or you could have pulled out a negative. Either way, you end up with a positive on top, which is exactly, looking at my prove, what I want. And on bottom, I would get a negative cosine and a positive sine, which is rearrangement of that. But it is technically the same thing. Negative cosine of x plus sine of x is the exact same thing as, addition is commutative, sine of x plus a negative or minus cosine of x. Check QED. Does anybody keep going? Wouldn't you have had to multiply top and bottom by the cosine of x minus sine of x? You guys see that minus, right? We gotta do distribution. But I'm gonna get minus sine x cosine x. I have another minus cosine squared over here because they have like denominators now. Put those fractions together. What happens to your cosine squared of x's? Isn't it the same exact thing as over there now? I have the exact same expression that is so close and only off by a sign. So I can actually multiply top and bottom by a -1 or factor out a negative. Both ways work and get you a positive. If your signs are ever completely backwards, multiplying top and bottom by a negative will always straighten it out, as long as your work is correct. I don't really know if I could say which one's easier. I think this one ended up kind of having like a little bit less of a step in one of them, but it was pretty stinking similar. But what did I see? I'm trying to give you guys strategies like insight into how to process these problems. I saw a tangent and he doesn't belong in the proof. So somehow I had to use an identity. And I saw two pieces, like we saw in section 5.1, and whenever there were two pieces, a fraction and a non-fraction, we always had to get a common denominator to put them together. Just a few little insights as to what made me go a certain direction. Our last two examples, and to be honest, they're actually pretty easy. They look disgusting. They look weird. But if you look at your identities, you're going to see in number 33, there's a really nice identity for number 33. Can you guys be writing down number 33 and then looking at your table? Because you don't have all these memorized, but look at your table. Aren't there ones with pi over 2s? Yeah, there are. What's the title? Because remember, we're memorizing those formulas with titles. Co-function. So if any of you guys are going back to the table, the identities to look at the different formulas. Look at the co-function properties as I rewrite the left side saying, hey, he's my given. Because we're not going to choose that right side. How do you get one? I don't know, 1,012 different ways. I don't know what to do with the one, but I do have something for him. It's going to look like magic if you don't look at your table. It's going to look like magic if you don't look at your table. Those of you guys that see it in your table, use it and just finish it off. But those of you that don't, I'm looking back at my table real quick. Isn't there one with, yeah, right here. Why is that awesome? Yeah, I was already telling us it's only 2 steps. Let's see if all of you guys can figure out why. If I put a cotangent, isn't cotangent and tangent, aren't they somehow related? Yeah, they are. Because cotangent is the reciprocal. And if it's the reciprocal, what happens if I multiply something by its reciprocal? Always, always, always. Look at that. But what would you have done if you didn't use the formula? Something illegal, to be honest. A lot of people would say, like multiply, right? It's about as bad as doing like, oh, I can distribute, right? No. It's stuck and you can't distribute. And you're killing puppies if you try. People try to distribute square roots. They try to distribute tans. I mean, never mind. But anyway, pretty easy one if you use your identities. This guy, not quite so easy, not quite so straightforward. I'm going to actually move him to the middle of the screen to make lots of room in my tea. I think you'll see it, and I think you'll understand it. But as we go into this very last example, see? This very last example, guys, please, please, please know that I do examples to help you in homework. But what do you need to do when you do your homework? Show work and have the notes close. Look at the notes, look at the problems and say, is there anything in common? Is there anything similar? Do one problem like every single one of your homework. We don't have time for me to explain and go through every single possible scenario. But I've chosen really, really good ones on purpose for examples to help you. So have your notes close, okay? This one, I'm not going to ask you many questions because it's kind of weird. So I'm going to show it instead, okay? Choose the left side, but write it way over here to the left and make your square root super, super long. You might want to put a little highlighter by this one because there's a lot of illegal stuff that kids like to try, like saying, square root, square it. But if you square it, you have to go to both sides, and you're doing your given and your prove, and that is so illegal. So we can't square. So instead, we do something that looks magical, or it will look magical in just a second, but it's actually just math. I want a cosine, which could come out of a square root if it was squared, which could come from 1 minus sine squared, which will only happen if I multiply by 1 plus sine. Or I want a 1 plus sign, which can only come out of a square root if it's squared, but it will only be squared if it's multiplied by itself. There's a couple different ways of looking at it. I can't square, but I can multiply top and bottom by something. And if I'm totally cheating, but in a totally legal mathematical way. I'm seeing what I need, and I'm saying, fine. And then I'm going to end up with 1 plus sine squared on top. I'm allowed to split up square roots. That's a mathematical property. With division or multiplication, totally legal. I'm going to FOIL this one because he's not a perfect square. I'm going to get 1 minus sine squared, which would be killing a puppy if I tried to square root. I can square at the top just fine because the square root and the squared simplify. I can do the top, but the bottom I can't. But Joe's already saying, hey, that's a Pythagorean-y guy. Isn't that cosine squared? And as soon as you get cosine squared, squared, some of you might have thought there should be an absolute value on top. Long story short, square root goes away. There's a couple reasons. Joe's already thinking through sine. Sine only goes between 1 and -1, which means this will actually never go negative. There's a reason why there's only an absolute value on one. If you put absolute values on both, hopefully you would realize, okay, basically I got it. I would count it. But this is kind of crazy because literally, as Jason said, I pulled this out of nowhere. Well, I looked here and used it to pull it out of nowhere. But hey, it ends up working, and now you have it in your notes as an example. So when you get to the homework problem that looks similar to this, you can use a similar strategy. Okay? Why is homework going to be nice? There's no reason at the back of the book for the final answer, because don't you know what you're trying to prove? Now, could Calc Chat give you some steps? For the odds, yeah. For the evens, no. But what's going to be super frustrating? You know what you're supposed to be getting to. The problem is, how do you get there? Let's see how you do, what you do, how you get there. Hopefully you have someone on call, and Honors Precalc kid would be a great one because they have their homework that, well, we did a lot of similar problems just about a month ago. So check in on them and maybe they can help you out. Sound good? Yeah. All right, guys, happy Friday. You made it. Get out of here.